So we have two more formulas to go. One's called the law of sines, the other's the law of cosines. And the way we're going to kind of look at these is in the context of solving a triangle. By solving a triangle, what I mean is if I give you some information about it, a couple of sides, maybe an angle, can you find the values of all of the other missing dimensions of the triangle? Okay, and there's several cases that we're going to be able to do with these, and I've listed them out here. And kind of using the familiar geometry language, right? We're going to be able to take, for example, the angle side angle case, right? So if I give you an angle and a side and an angle, so you know this value, and this value, can you find the lengths of the other two sides and the third angle? Those are the kind of scenarios we're going to be looking at. Okay, so we're going to start off with the law of sines. And this is the formula, right? It's this geometry form, as trigonometry formulas go, it's relatively easy to remember, right? You take the sine of an angle, divide it by the length of the opposite side, right? That's sine A divided by A, for example. And that ratio is the same no matter which angle side pair you pick. And I want to emphasize something about this, okay? We're not talking about right triangles anymore. This formula applies, right? This formula works for any triangle, not just a right triangle. All right, so let's see how we can use this. Let's look at some examples. So this is the side angle case, all right? I have, let me kind of sketch out my triangle here so we have something to look at. We'll call this side A, so we know this side. We know the opposite angle, that's 25 degrees. And let's call this one down here angle B. This one is 42 degrees. I want to fill in all the missing stuff, right? I want to fill in the missing sides and the missing angles. Missing angles, one. Okay, well, if we're down to missing one angle, that's always easy, because remember, the sum of the angles, the sum of the measures of the angles in a triangle is 180 degrees. So if I call this one X, then 42 plus 25 plus X equals 180. If you subtract 42 and 25 from both sides, we get X equals 113 degrees. Excellent. One down. Okay, now I got to find the missing sides, right? So I have to find B and C. Well, I'm going to use my law of sines, which I've got up here in the right-hand corner as a reminder. So let's see. To use the law of sines, you always have to know one angle side pair. And I've got that here with A. I know angle A, and I know side A. So I'm going to do the sine of 25 degrees divided by 3 equals, and let's go for side B here. So this is going to be sine of 42 degrees divided by B. And now I just need to solve this, right? Let's cross multiply. B sine 25 equals 3 sine 42. Divide by sine 25. B equals 3 sine 42 divided by sine 25. And my calculator tells me this is 4.75. And so there is B. Now I'm going to do it again. Right? I'm going to do the same thing over again to find side C. I'm going to do sine of 25 divided by 3 equals the sine of, see, I'm finding C, right? So this is the angle I calculated down here. Sine of 113 divided by C. And again, we'll cross multiply. C sine 25 is 3 sine 113. And then divide. C is equal to 3 sine 113 divided by the sine of 25, which my calculator says is 6.53. Okay, let me put my 113 degrees in here. Now, there's a quick little check we can do. It's not perfect, right? It's just kind of a little reality check. Remember, there's a geometry theorem that says the biggest side has to be opposite the biggest angle, and the smallest side has to be opposite the smallest angle. So we can check that. 113 is the biggest angle, and 6.53 is the biggest side. They're opposite each other. Excellent, that works. 25, angle A, is the smallest angle, and at 3, yes, side A is the smallest side. Good, so that matches up. It's not a guarantee we didn't make an arithmetic or a calculator mistake somewhere, right? But it's a good quick reality check, give you a little more confidence in your answer. Okay. Now how about the angle side angle case? All right, well, again, let's start with a diagram. Right, I'm going to sketch in a picture here. Right, it's going to look something like this. I have angle A, that's 18 degrees, and I have angle B, that's 75 degrees, and side C, see that is angle side angle, this is the side in between, that is 5. Now, it's not looking good for my law of sines, but we can do this. Remember, because I told you we have to know a sine angle pair, and I wasn't given that, but remember I can find angle C just by using that 180 degree rule. 18 plus 75 plus the measure of angle C is 180 degrees. So the measure of angle C is subtract those angles there, and what do we end up with? Let's see, 105. That's going to come out. That's 87. Sorry, I had a little slip of gear there. 87 degrees. That is our third angle. Okay, and now we can fall back on the law of sines. Right? I'm going to do. Let's see. I'll find B first. So sine 87 degrees divided by 5 equals the sine of 75 degrees divided by B. Right, then you could do the cross multiplying if you like. You multiply both sides by B, bring the B over to the left side, however you like to solve these kinds of equations. You'll end up with B equals 5 sine 75 degrees over the sine of 87 degrees, which my calculator says is 4.84. So let's put that in here. That was B, right? 4.84. And then we'll have to do it one more time. I'm going to do sine 87 degrees divided by 5, and I'm looking for A this time. So I'm going to do sine 18 degrees divided by A. You do your cross multiplying here. You end up with A equals 5 sine 18 degrees divided by the sine of 87 degrees, which again, according to my calculator, is 1.55. So A equals 1.55. And again, I'm going to do my little check here, right? 18 is the smallest angle, 1.55 is the smallest side. Good. 87 is the biggest angle, and 5 is the biggest side. Not by much. And that's good too, right? 87 degrees and 75 degrees, they're pretty close to each other. This is close to being an isosceles triangle. And yeah, those sides are pretty close to each other. So that, again, is kind of a second little check we can do to get some confidence in our solution. Okay, so those are the two easy cases. The third one, right, that's the side-side angle case. That one is a little tricky. With that one, sometimes there are going to be two possible solutions. It actually has a name. It's called the ambiguous case. So that's what we're going to look at in the next lecture.